Hey folks, welcome to the Neo4j stream. My name's Will. Sorry we missed last week. I was on vacation, but back this week to our regular schedule every Thursday at 2 p.m. Pacific, which is about now. We dig into GraphQL and GrandStack on the Neo4j stream. So previously we've been working on this real estate search application, which I think we've made pretty good progress on. Last time we did protecting mutations with Auth0 and forms in React, so we can add listings now. So I think we'll take a break from the real estate search app, since we have pretty functional application there, and dig into something new. And what I want to do with this new project is build a travel guide. So a website that's going to show me some points of interest and how I can get between these points of interest, so some routing. And to do that, I'm going to use Neo4j, Gatsby JS, and GraphQL. So today we'll be just sort of digging into the different pieces and taking a look at how to get started with Neo4j and Gatsby, and a heavy focus on GraphQL, since GraphQL is how we'll be getting data out of Neo4j and into Gatsby. So let's just jump in and take a look at Gatsby. So if you're not familiar with Gatsby, it is a framework for building websites. Some people refer to it as a static site generator. And basically what Gatsby does is it uses GraphQL as a data source. So if you have content, say in a CMS, in Markdown files, in a database, it uses GraphQL to bring that content together, and then uses React to build the web application and generates static site content using GraphQL as sort of the content source. Full disclaimer, I know that's about all I know about Gatsby at this point, so this will be a bit of a learning experience for me, for sure. But that's my basic understanding of it. I know you can also bring in third-party GraphQL APIs. So Gatsby itself has a GraphQL API that it uses as part of the build process to build the web apps. And we can hook in our own third-party GraphQL APIs into that GraphQL API, into the Gatsby GraphQL API. And so that's what we want to do today, is take a look at how we can use some of the GraphQL tooling for Neo4j to build a GraphQL API on top of Neo4j, and then feed that into a Gatsby build process. Cool. So let's go ahead and get started with Gatsby. So we go to the quick start. We can see there's a Gatsby CLI. So I have already installed that. So I have the Gatsby CLI ready. And then creating a new site is as simple as a Gatsby new command. And then we can use these Gatsby starter projects. So let's take a look at the starter library. So there's lots of different starter projects that we can start with for Gatsby. 441 of them. I think let's just pick a fairly simple one. So Gatsby starter blog. Let's take a look at this one. So a blog landing page showing some blog posts and then, yeah, some static content. So this looks like an okay place to start. So if we imagine for our travel guide, we can have sort of a post entry for each point of interest that's going to show some information about the point of interest, what it is, bring in some photos, route us to other points of interest, that kind of thing. So this looks like a good template to start with. So let's see, let's copy the URL for this starter back to our quick start. Okay, let's create a new project here. I'm going to call it Central Perk. That will make sense in a minute when we look at the Neo4j data that we're actually going to use for this. So let's see, let's get this out of the way here. Okay, and then we do Gatsby new, let's just call this Gatsby, since this is inside our Central Park directory. Well, we'll call it Gatsby site, sure. Okay, and then the URL for the starter. So this is pulling down the Gatsby blog starter and creating a new project for us. If you have any questions or thoughts, feel free to ask in the chat. Okay, so we've created a Gatsby site. Go to Gatsby site, we can do Gatsby develop. And this, I think, should do a couple of things. One is it should spin up a GraphQL API. And that is the GraphQL API that has sort of all of the content. And then also it builds our Gatsby site at localhost 8000. Let's take a look. Localhost 8000. Here's our Gatsby site, and then if we go to localhost 8000 /__ GraphQL, then we get the GraphQL API for our site. Cool, so this is the API where during the build process for Gatsby, it's pulling in all of the actual content. Lysanne says hi in the chat. Hello, thanks for joining today. So, for example, if we take a look here at some of the entry, let's say all site, page info. Not a lot of info there. How about page info, all site, nodes. We can pull in build time, host, parent, what we want for the actual content. Let's take a look here at the source, and we'll see what GraphQL query we're actually running to populate this. So let's open up VS Code. And let's see, let's do a little manual split screen here. There we go. Okay, so Gatsby site, we take a look at the Gatsby config. We have some plugins here. So Gatsby source file system in a few different directories. So making, this is pulling in some assets from the file system into the GraphQL API. It's using Remark, which is, I think, a markdown parser. So I think most of the actual content for this comes from these markdown files, which are the actual blog posts. What we're going to want to do is kind of replace these with content from Neo4j. And let's see, if we look at Gatsby node, so this I think is what runs GraphQL query to see all of the pages that need to get built. So let's copy this query. Oh, failed to fetch because we stopped the Gatsby server. So let's start that again. Gatsby develop. And this will spin up our GraphQL API and build the site again. Okay, so now we should be able to run this query. And yep, cool. Now we can see, so all markdown remark. So this is getting, I guess, all of the pages that are being processed by the remark markdown parser. And then showing us that the slug for each page and the title for each page. So I'm guessing this is all of the pages that need to get built. And then if we look at, not in contents, but in source, pages, index, we can see, so this is the React code for the index page. We can see the GraphQL query that we're running for that as well. So let's just run that query as well. And here we're getting, so some site metadata, then all of the pages, and then we're bringing in a few more fields. So now the front matter. So the front matter, if we look at these markdown files, content, blog, hello world, the front matter is are these three fields here. So we have title, date, and description, title, date, and description, and GraphQL. Okay, cool. So this is sort of mapping things in Markdown to GraphQL as part of that process. That's neat. And if we look at the templates, blog posts, so for each post, here's the React components that are rendering based on the data coming back from the GraphQL API, which is this query. So blog post by slug. So, oh, I already pasted in the slug for one of the pages. Let's close the Explorer there. And here's where we're bringing in the actual HTML content, so the actual content that gets rendered for each blog post. And in this case, for the blog post with the slug new beginnings. Okay, cool. So we can kind of see what's going on here with how that GraphQL API gets built using these plugins. So like parsing Markdown to GraphQL, and then the build process uh, runs this GraphQL query, renders these React components to build the static site. Okay, cool. That is, I think, good enough for a basic understanding of what's going on here. Now, the next thing we want to tackle is pulling in third-party GraphQL content. So I know what I want to do is build a GraphQL API on top of Neo4j with some data that I want to pull into my travel guide site. Assuming I have that GraphQL API, how do I hook that into the Gatsby GraphQL API for this build? Well, if we take a look, Gatsby GraphQL using third-party GraphQL APIs. That's what we want. So for this, it says we need to use the Gatsby source GraphQL plugin. And then in our Gatsby config, we basically point it at the GraphQL API, and we give it a namespace. And then it looks like that GraphQL API is then kind of stitched into the Gatsby GraphQL API, and we can then query it using that namespace that we gave it in the config. Cool, so that sounds straightforward enough, but we need a GraphQL API. So first, let's spin up a Neo4j Sandbox instance, and I'm going to use a specific Neo4j Sandbox. So this one is hidden, that has a specific URL to unlock it. So let me drop that in the chat. So it's neo4j.com/sandbox use case equals OpenStreetMap. We'll take a look at this in a second. So question in the chat. Currently using Neo4j for knowledge graph creation, but my requirement is to create multiple databases in one Neo4j instance. Is it possible to have multiple databases? Yes, it is. Oh, and then he says using Neo4j version 3.5. So you can create multiple databases in Neo4j. Managing multiple databases in Neo4j. This is probably the best resource of the developer guide on working with multi-database. Yeah, so multi-database is not available in Neo4j 3.5. This was introduced in Neo4j 4.0. So let me drop this link in the chat so you have that. So if you want to take advantage of this feature, then take a look at upgrading to 4.0 because it is not available in 3.5. And basically, this guide goes through sort of creating two different databases, switching between them, loading, looks like loading the Northwind data set into one and loading the movie database into the other. But cool, yeah, good question. Okay, so if you haven't used Neo4j Sandbox before, this just allows us to spin up Neo4j instances that are loaded with specific data that are private to us. So if you haven't used it before, you'll just need to sign in with like Twitter, GitHub, or create an account. And I'm going to launch this OpenStreetMap data set. If you participated in the Summer of Nodes, then you've probably seen this OpenStreetMap data set before. So what this is, it's a data set of OpenStreetMap data from Central Park in New York that includes point of interests and ways. So that's OpenStreetMap terminology for things like the pathways that are in Central Park that are connecting points of interest, or the outline of buildings, the outline of fountains, and things like that. So let's open this up. So what we're going to do is take a look at this OpenStreetMap data set, and specifically we'll take a look at the points of interest. So the points of interest here are going to be kind of the things in the travel guide that we're going to show detailed information about and show how to route from one point of interest to the other, and that sort of thing. Okay, so here's the Neo4j Sandbox. Let's do a call DB schema visualization to give us an idea of the schema. And this looks a bit like a rat's nest here, but a lot of this we won't need to think about. So what's going on here? So the tool that we use to create this data set, by the way, is available on GitHub. It is Neo4j contrib, just OSM. Yeah, so this is the OpenStreetMap importer for Neo4j. We'll drop that link in the chat. And basically, the way this works is you give it a OpenStreetMap dump, so you can download OpenStreetMap.org. Yep, you can download data from OpenStreetMap either in this tool, or when we're zoomed into Central Park. So what we have is this area here. So all of Central Park and the crowdsourced data. So OpenStreetMap is crowdsourced, so it's people sort of going around and saying, hey, there's a sidewalk here, hey, there's a building here, there's a road here, adding in some attributes and whatnot. So all of the data that is populating this map comes from crowdsourced data that has been uploaded to OpenStreetMap. And OpenStreetMap is super interesting. It's a very rich data set. There's all kinds of attributes and tags about the different ways that are included in OpenStreetMap, and it's great for routing, finding points of interest, and actually I think this data powers most of the major mapping applications. Faison says, thanks for answering. Look at updating to Neo4j. Reason using 3.5 was GraphqL Elasticsearch plugin. Hopefully that works with 4.0. Yeah, I'm not sure. I would imagine that there is a 4.0 version of the GraphqL Elasticsearch plugin, but I'm not sure. But I would imagine that that there is. If you can't find what you're looking for or run into any issues with that, you can always ask on the community site for Neo4j. This is a great resource, community.neo4j.com, which is a forum where you can sort of ask questions, and folks will help you with all your Neo4j questions as needed. Okay, so what I did is I took an export of OpenStreetMap, just of Central Park, ran it through this OpenStreetMap importer for Neo4j, and then that's what we used to create this sandbox data set. But you don't need to do that. That's just kind of an idea of how you can create this data set for sort of your own area of OpenStreetMap that you're interested in. But okay, so here's the data set. So we have points of interest. They are connected to OSM nodes, which are connected to OSM way nodes that are connected to an OSM way. We have some metadata in OSM tag nodes. So that's kind of the base OpenStreetMap data set where we have ways, and ways in OpenStreetMap can be anything from a street, a sidewalk, a building. A ways is kind of like a generic term for like a feature, might be another word. And then all of the actual sort of observations. So as someone is going around crowdsourcing data to upload, they say, okay, here's a way, this is a sidewalk, and then they go along and sort of walk different paths of the sidewalk and upload what become OSM nodes that have a latitude and longitude associated with them. So a way is really, in this model, is really a linked list of OSM nodes, each with its own latitude and longitude. We'll take a look at one in a minute. And then what we've done is built sort of a routing graph on top of that. So if we're interested in how to get from one point of interest to another, well, what we want to do is really just sort of find the intersections that connect the different ways. So there's this routing graph that is basically made up of these intersection and routable nodes that sort of sits on top of the collection of these ways. So to find a route from one point of interest to another, we basically just follow these route relationships connecting intersections. And then of course those intersections are then connected to the ways which have the actual data for the route that we're taking. Let's take a look at an example here. So let's find a way. Here is West 90th Street. And so this node represents a single way, in this case, West 90th Street. We find that on our map. 86th, 96th, east. This is the east side. Here's west. So here's the West 90th Street. So it's representing this way. It doesn't cut into Central Park, so I think we probably won't have too many observations here, but just kind of around the edge. But okay, so we have this tags relationship. So this has some metadata. Maybe I can make this a bit bigger so that's easier to see. Zoom in a bit. So this OSM tags node has some metadata about West 90th Street. So can we ride bicycles on it? Yes. Highway. This is a service road. It has a name. Yes, it's one way. We have some metadata. Then we have this first node relationship to the OSM way node, and then that's connected to the OSM node. So this OSM node kind of represents the thing that has been actually sort of crowdsourced. Someone says, hey, here's the latitude and longitude for this point. And then we have this kind of linked list of more OSM way nodes that are connected to more OSM nodes. So if we were to just continue on this linked list, each one of these represents a point on West 90th Street. And you can see that this routing graph is sort of built on top of that. Okay, so those are the ways. And then we've added these point of interest nodes. Let's take a look at those. Um, how about the Dancing Crane Cafe? Seems like a good one. So some of these OSM nodes, based on the tags that they have, might have attributes like restaurant or cafe or something like that, or fountain or museum. And so in that case, we know that they have some amenity, so we mark them as a point of interest. And in this case, this is the Dancing Crane Cafe. It's of type cafe. It's connected to a tags node that has a bit more metadata about it. You can see some of the other things we have are, here's a statue, the Fitzgreen Halleck statue. Here's the pond, which is a body of water. So what I want to do is expose a GraphQL API that basically just exposes the point of interest, the points of interest. I'm not necessarily interested in sort of the routing or the more detailed graph of the OpenStreetMap data. Instead, I just sort of want a way to find points of interest within our data set so we can pull that into our travel guide. One thing we do want to do, though, is to be able to handle routing, which we can do in Neo4j. Graph Database is great for routing, finding efficient paths from one place to another. So let's take a look at how we would do that. So let's say, how could we find a route from, let's just pick these two, from the pond to the Dancing Crane Cafe. So I don't know what you do in the pond. Is this where they rent the boats in Central Park maybe? So I've been rowing my boat in the pond, and now I'm ready to go to lunch at the Dancing Crane Cafe. Let's see if we can write a query to find a route from one to the other. So starting off, find point one is going to be a point of interest where the name is the pond, and P2 is going to be a point of interest where the name is the Dancing Crane Cafe. First off, let's just see if we can find those. Yep, there we go. So 2 points of interest. Cool, so how do I find a route between them? Well, we just follow these route relationships, and we can see pretty quickly we have lots of choices. So first off, from the pond, we can follow this route relationship, but then we have to decide, oh, do we go this way, this way, this way? Do we go towards the Thomas More statue? And you can see pretty quickly that as we expand out this graph, there's lots of route relationships to follow. So we want to take the shortest path from the pond to the Dancing Crane Cafe. We can do this in Cipher with the shortest path function. So this is going to look something like this. We're going to say match P equals shortest path from P1 following route relationships. It's always good to put an upper bound here. Let's start at 200 and see if we find a path to P2. And let's return the path. Cool, and here's the shortest path that we found. So it follows these OSM nodes. And each one of these has a latitude and longitude. So if we wanted to, let's say we wanted to plot this on a map. So we need the latitude and longitude for each one of these OSM nodes to draw the path. We can do that by unwinding over the nodes in the path and returning, let's say, just make an object to return for each one of these. So the latitude is going to be in dot, unwind node p's as in dot location. So location is a point property on each one of these in dot location dot latitude, and longitude is going to be in dot location dot longitude, and that should return our path. Cool. So here's all the points that make up the shortest path from the pond to the Dancing Crane Cafe using Cipher's shortest path function. This may not be the actual shortest path. We'll take a look at that later on. But what this means is the shortest number of relationships. So the shortest number of hops that we make. But if we look at these route relationships, we can see that there's a length. So sort of or rather a distance. So from this point to this point, it is 10.39 meters. From this point to this point, it's 5 meters. So these are not sort of evenly spaced observations. Remember, this is crowdsourced data. It's not sort of evenly spaced out with an observation every meter or something like that. And so really what we want to do is use like the Dijkstra or the A* algorithm to find the shortest weighted path. So the shortest distance is what we're really interested in. But it's good enough for now. So question, what does the topography stuff do in Gatsby? I always wondered. Yeah, I don't know. I'm assuming with Gatsby, so it's my understanding you can import pretty much any React styling components. So I'm assuming it has in the template that we chose some topography styling, but I don't know. We'll have to explore that. Like I said earlier, I know very little about Gatsby. I've never actually used it for anything. So this will be a fun thing to dig into. Okay, so we've got our data in Neo4j. We kind of know that what we want to make available out of Neo4j and Gatsby, the points of interest and some of this routing stuff. Okay, great. Now we need to create a GraphQL API that is going to expose this data in Neo4j to Gatsby. So let's switch over to VS Code, and I'm going to create a new directory alongside, oh, not in it, up here. Let's just do this in command line. mkdir, what should we call this? Let's just call it Neo4j GraphQL, I guess. And in Neo4j GraphQL, we'll do npm init-y. So we're going to create a new npm project and create index.js. From the chat, Soccer Nuffin says, I got Gatsby working with Apollo, Auth0, and Neo4j. Oh, cool. Great. You'll have to tell me what I'm doing wrong then when we run into some errors. Cool. What was the project that you built with Gatsby and Neo4j? If you have a link to it, definitely feel free to share that too if you like. Okay, so we're going to start a new project here. So what we want to do is create a GraphQL API using this data from our Neo4j Sandbox instance and then hook that into the Gatsby GraphQL API. So let's install a few packages. We'll need Neo4j GraphQL JS. If you're not familiar with Neo4j GraphQL JS, it's part of the grand stack. Take a look at the docs here. So the goal of Neo4j GraphQL JS is to make it easy to build GraphQL APIs backed by Neo4j. So it includes basically the functionality for defining some GraphQL type definitions, pointing it at a Neo4j instance, and takes care of all of the data fetching and generates a schema, GraphQL schema on top of Neo4j for us so that we can just expose that data out of Neo4j with with writing minimal code. So we'll definitely want that. We'll also need the Neo4j JavaScript driver. And we'll need Apollo server, which we'll use to run our GraphQL API. So Neo4j GraphQL JS works with any JavaScript GraphQL server, but Apollo server is a nice one to use. Cool. Starting off, let's not think about Babel for now. So we will pull in, if we look at this example, the quick start for Neo4j GraphQL JS, we're going to kind of follow this basically. We're just importing make augmented schema, define some type definitions, create a driver instance to connect to Neo4j, create an Apollo server instance, pass in our schema that we create with make augmented schema, inject the Neo4j driver instance, and then spin up Apollo server. So we want to import make augmented schema from Neo4j GraphQL JS. We want Apollo server. And we want Neo4j driver instance. And we need to define some type definitions. These are just these as a string, but we can put in this hint so that we get some syntax highlighting from VS Code. Okay, well, if we go back to our database, really what we're interested in is exposing the point of interest node. So I think we'll just start off with one type here in our GraphQL schema. So with Neo4j GraphQL JS, we map the node labels to types in GraphQL. So if we have that one-to-one mapping, we just have to define the types that map to the property graph type. So in this case, the shape of our graph in Neo4j, and we don't have to write any data fetching code. That Neo4j GraphQL JS library will take care of generating Cipher queries to fetch data for us. So type point of interest, this represents the point of interest nodes. And what properties do we want to expose? Well, they have a name and a location. That's a point. With one thing that's nice with Neo4j GraphQL JS is it adds the database types as well. So we can just say point here, and it knows that's referring to a point type in the database. A type. And what else? We have this OSM or node OSM ID, which I think is an integer. Sucker Nuffin says, happy to help out. We stumbled on any issues. Nothing we're sharing just yet. Okay, cool. Yeah, well, definitely let me know as we run into issues, how you solve them. That'll be helpful. Okay, that's probably good enough for now. We're just going to expose some point of interest nodes. Let's create our schema, make augmented schema, and pass in our type defs. And then we need to create a driver instance. The connection string for our sandbox instance, which we can find here. So this is the bolt URL, which is the connection string that the driver takes. And then we need, what is it, Neo4j auth basic username and password. So Neo4j is the user, and here is the password. Okay, so we've got our driver instance, we've got our schema. Now we create our Apollo server instance. Server equals new Apollo server schema, and then the context object. So this is a object that's passed to every GraphQL resolver, which we don't need to write, but the resolvers are the functions that contain the logic for actually fetching data, in this case from Neo4j. And these are generated for us by this make augmented schema process, but we do need to inject this driver instance that we created here that contains the connection to our Neo4j Sandbox instance. That is going to ensure that our GraphQL API is able to connect to Neo4j. And then let's spin up our server. We'll do it on port 3003. I don't think I have anything running there. And this gets the URL, I think, that we can log. Something like GraphQL ready at the URL, something like that. And let's start up our server. It's running on localhost 3003. And if we take a look at the docs, we see we have a single query entry point for point of interest. And we can see we've added some things like pagination and filtering that we get for free. Zoom in a bit. Cool. So we wrote a query that says, show me the first 10 points of interest, their name. We can add type. We can add latitude and longitude. Cool. So that's good. What else do we need to do? Well, we need to expose that routing. So, oh, and we also have tags. Let's jump back here. So if we take a look at this tags relationship, so there's an OSM tags node that most of these points of interest are connected to that has metadata about the point of interest. So this has, like, if we look at the point of interest node, all we know is this is a statue that has a name of Walter Scott. But if we look at the OSM tags node, well, then we can see here that the artist name was John Steele. It's a statue that was built in 1872. And it has the Wikidata and Wikipedia entry that we can pull in. So this will be a good thing for our travel guide, is that if we have any of these sort of Wikipedia or Wikidata entries, we definitely want to pull that information in as well, since the idea is this is a travel guide to give you information about the points of interest that we're looking at. So definitely want to include these tags and think about how to include the routing as well. So this is going to be interesting because these tags, these are kind of arbitrary key value pairs. Here we have information about a statue, but if we look at the tags for the Dancing Crane Cafe, we have different values. So this is an amenity, that's cafe. If we look at the pond, we have for the pond just that it's natural water. So you can see we have kind of different key value pairs, kind of depending on what it is that we're looking at. And so because GraphQL is strictly typed, we'll need to think about how we want to handle that. For now, what I'm going to do is add a tags field that will be a list of strings, and I'm going to use the Cipher Directive field to populate this. So the Cipher Directive, let's take a look in the docs. Cipher Directive. So the Cipher Directive allows us to basically bind Cipher statements to fields in GraphQL. So it allows us to add some custom logic to our GraphQL schema that we define with Cipher without having to write resolvers or having to write much code. So in this case, what I want to do, so this takes a single statement argument, which is a Cipher statement. So we're going to say match this. So this is a keyword that refers to the point of interest node. It's helpful to look at the graph here. Refers to the point of interest node that's currently being resolved. And what I want to do is traverse from that Fulling's tags relationship to this OSM tags node. And I think what we'll do is just return, maybe to start off, just the keys. So for all of these arbitrary key value pairs, give me just the keys in this tags field. So when we request the tags field in our GraphQL API, it'll run this little Cipher snippet to find that for each node. Restart our server. Oh, let's install node mon so that we can set up a watcher so we don't have to restart this every time we change the schema. And then in package JSON, for the start script, we'll say nodemon index.js. That'll work. So now we can say npm run start. Cool. And now, anytime we change index.js, or if we change our GraphQL schema, it'll restart our GraphQL API. Cool. Okay, so now can we add the tags field? Yeah, so it's like, so some of these appear not to have any tags, but some of them do. Cool. The other thing we want to add is some routing. So we saw earlier how to, for example, here, how to use shortest path between 2 points of interest. So let's add another Cipher Directive field. Let's call this route to POI, and this is going to take a argument. So one thing that's nice about these Cipher Directive fields is that we can add arguments, so field arguments, to these that then get passed as parameters to the Cipher query, which is nice. So a question in the chat, I've been using the Python driver. I see latencies have gone up for requests which involve bolt connection, how to bring them down. Yeah, that's a good question. I mean, there can be a lot of things there to look at. So I guess I would start, looking at profiling the Cipher queries themselves. So for any Cipher query, if you attach profile or explain to the beginning of your query, you can see the query plan. And if you use profile, it will actually run the query and give you this metric called the DB hits. And basically, if we're trying to optimize queries, what we want to do is minimize the number of DB hits for any query. There's a good section in the manual that talks about query tuning. So this talks about looking at the different query plans that you're getting and sort of operations that you might see in the query plan that could be potentially expensive and ways you can adjust your Cipher query to make that a bit faster, and things like using index hints and that kind of thing. So that's one thing to think about when you're trying to reduce the latency of your query. The other thing to look at are, making sure that you're using the driver transaction functions in Neo4j. Transaction functions. So by default, there's these auto commit transactions where you say sort of session.run and then pass in a Cipher query. Those are good for like testing and development, but really you want to use the transaction function API, which are these. So that's one thing to look at, and always make sure that you are closing the session when you're consuming the results and so on. So cool, yeah. So there's some things to look at. So question, I'm not seeing the other messages. Yeah, so we're streaming both to Twitch and to YouTube. So you may not see some of the other comments. If you're on Twitch, you won't see the YouTube comments. Or if you're on YouTube, you won't see the Twitch, but I see them both. So if you're on either, feel free to ask in either chat, and I can see both of those. Cool, a question about looking for someone to help an in-house engineer with implementing GraphQL on top of Neo4j for mobile real-time application. Any referrals? Yeah, cool, that's great. I would suggest posting on the community site. There's a section here for jobs and consulting opportunities. And then also in the Neo4j Slack, neo4j.com/Slack, I think, will give you an invite. And there's a Neo4j GraphQL channel in the Neo4j users Slack group. So I would definitely post in there that you're looking for someone experienced with Neo4j GraphQL to come on as maybe a contractor or something like that. There's a lot of knowledgeable folks that are using Neo4j GraphQL in production that hang out in that Slack group. So I would start there. Okay, cool. So we want to expose some of this routing functionality in our GraphQL API. So what we want to do is, right, add this route to POI field in our schema, which is going to take a argument, let's call it POI, and this is going to be an integer. So this is going to be, find me the route to some other point of interest, and we'll pass in the node OSM ID. We can also do the name, I don't know, the ID. That ensures we're only going to find one. Okay, and then this is going to give me a list of points. I don't have, it's not going to return like the same thing as a Neo4j database point type. Rather, it's going to be a pair of longitude and latitude. So I'll call it step, because we may start including some other things, maybe like the direction that we're going or something like that, when we want to draw this on a map or something like that. But anyway, for now, this will be latitude and longitude pair. So our route to POI is going to return a list of these step types. And again, we're going to use the Cipher schema directive. Oh, I think someone previously had asked me how you can have syntax highlighting in these Cipher directive fields. So I've noticed here, our Cipher is just kind of treated as a string. There is a Cipher template tag that gets exported from Neo4j GraphQL.js that we can use inside these. So we can say like Cipher, and it's a template tag. So like match, oh, we need to evaluate this since we're inside a string literal. So evaluate that, cool. And now we should have Cipher syntax highlighting. So, okay, so for our point of interest routing here, it's going to be something kind of like this. So we're going to say, first of all, we want to match the other point of interest by matching on the node OSM ID, and we're just going to pass, because we defined a GraphQL field argument here called POI, that gets passed into this Cipher query as a Cipher parameter called POI. So this is the other node that we're going to route to. And then we want to do P equals shortest path. So find the shortest path from this. Remember, this in these Cipher directive queries refers to the node that's being resolved. So whatever point of interest we're looking at is this. And then we're going to follow these route relationships up to 200 hops. Always good to put an upper bound on there to the other. And then what we want to do, just like over here, where we then did an unwind over all the nodes in that path, returned a latitude, longitude object. We're going to do that. Unwind in the nodes in the path as in, and this query, we're expecting it to return this step object, which just has a latitude and longitude field. So we'll make an object. Latitude is going to be in.location. So each of these nodes in our route has a location property. in .location.latitude, and longitude is in .location.longitude. And we can alias this to something, doesn't really matter. Let's call it the route. So the question is, this equals point of interest? Yes, exactly. So this right here is going to be a node of point of interest, and specifically, like if we take a look at our query here, it's whatever point of interest we're currently resolving. So when we're resolving here, the Jacqueline-Kennedy Onassis reservoir, this takes on the value of that node. So if we're routing from the pond, then it's going to take on the value of the pond node. Okay, let's see if that works. So we restarted the server. Let's just pick the first. Well, yeah, sure, we can look at the first, maybe handful of these, find a bunch of routes. Okay, so for the first handful, let's route to POI. Let's find a node to route to. How about to the Robert Burns statue? So let's copy that node OSMID. And then that's going to give us a bunch of latitude, longitude pairs, hopefully. Let's see what we get. Cool. So if we want to get from Jacqueline-Kennedy Onassis Reservoir to the, what was this called again? To the Robert Burns statue, we're going to follow these points, quite a few turns to get there. If we want to go from the pond, then this is the route that we're going to take, and so on. Cool, so that'll be useful so that we can draw routes on a map in our GraphQL API. Okay, so I think that's good enough for now for our GraphQL API. Now what we want to do is stitch in this GraphQL API that we've built, exposing data from Neo4j. We want to hook that in to Gatsby so that we can then use that data to populate our Gatsby site. So if we go back to this documentation using third-party GraphQL APIs, it says we need to install this Gatsby source GraphQL plugin and then set up some configurations. So let's go ahead and do that. So I'll open a new terminal tab. Oh, and the reason, you can see now the reason that we called this Central Park is because we have Central Park in New York data. It's a Friends TV show reference there, if you didn't get that. Anyway, okay, so into Gatsby site, I think we're using Yarn for this. So Yarn add Gatsby source GraphQL. And that's going to install a whole bunch of stuff. Oh, it's kind of quick. And then if we Gatsby site, Gatsby config, yeah. So in the Gatsby config, we have a whole bunch of plugins that we're registering. So we'll add an entry here. And it says resolve. So which plugin are we using? Gatsby source GraphQL. And the options, let's see, it needs a type name. This type will contain remote schema query type. Okay, so the type name, I think, is what we want. Point of interest. And field names. I think the field name is the field under which it's accessible. So I think this is like the namespace sort of. Let's call it POI. And then the URL. URL is, right now it's just running on localhost 3003, I think it was. So from the chat, you can use the Gatsby source GraphQL, but only for querying data statically. If you use Apollo, it's not necessary. Yeah, so what I want to do actually is use this to build static content. So what I want to do is kind of at build time, pull in all of this data from Neo4j through this Gatsby GraphQL API, basically like build out one page for each of these points of interest and build a static site. So essentially we're hitting this Neo4j GraphQL API at build time. So I think that'll be the first approach that we'll take. So we'll like build out our static Gatsby site. And then we can also then within, as we start to build out more the front end piece of this, we can then use Apollo client in the React application in Gatsby to then query live data from Neo4j. And that might be for our routes. Maybe that's when we pull in the routes is, I'm at one of the points of interest, and from a dropdown, I want to select the next point of interest to go to. And then at that point, then we go querying live the GraphQL API to find the route. But yeah, so that's what we're going to do initially is use this at build time to pull in data to build kind of static content. Cool. Let's see, anything on the Twitch chat? Link. What's the link for the YouTube session? The YouTube sessions are all, I think, youtube.com Neo4j Live, I think. So if you're looking for the YouTube version, it should be running there. Cool. Okay, so we installed the Gatsby source GraphQL plugin. We configured it. So now we should, do we have this running? I think we stopped it. Localhost 8000. Oh no, still running. Cool. So now if we go to ___ GraphQL, and if we take a look at Explorer, do we have a POI? We don't have a POI. Maybe we need to restart. Where did we run this? Not here. Here. Do we need to restart this? Is that why it didn't get picked up? Let's see. Okay, so that restarted. Cool, now we have a POI. Okay, so point of interest, name, type, location, latitude, and longitude. So this should give us all of our points of interest, their type. Oh, we also have tags. Tags. Cool. So now we're pulling in data from the Gatsby GraphQL API that has stitched in the GraphQL API that we built using Neo4j GraphQL.js, fetching data from our Neo4j Sandbox instance. And this has all of the goodies like our filtering and pagination and even like the routing fields that we added as well. Cool. So now we're ready to update the React front end for our Gatsby site to start taking advantage of this data coming from Neo4j. But I think that might be a good place to stop for today, since we accomplished a little bit. So I will go ahead and push this up to GitHub. Create the GitHub repo now, so we at least know where it is. Can I do /new? Does that work? No, does not work. New repo. Let's call this central perk. And this will be building a travel guide using Neo4j, Gatsby, and GraphQL. Cool, so here's the link to the code where I will post it up now. So definitely feel free to pull that down and play around with it. Next week, so again, every Thursday at 2 p.m. Pacific, we will pick up with now starting to update the React front end in Gatsby to actually make use of this GraphQL data that we've stitched in to our into the Gatsby API. Also, if you want to play around with the Neo4j Sandbox instance that we used, remember it's kind of hidden, so you need to use this specific URL, but I'll put that in the README on GitHub. It's kind of hidden for now just because we haven't built the guide for it. So when you first load one of these, so I'll refresh it. When you first load one of these Sandbox instances, the data is there, but there's also this browser guide that comes up, which has kind of interactive queries to walk you through exploring the data set, writing Cipher queries. And the guide we have in here, we use this as a challenge for the Summer of Nodes. So this was our fun community challenges to use some interesting data sets to solve some interesting problems. So we don't have a guide that kind of shows you how to actually explore the data. So anyway, that's the only reason that it's hidden. But if you use that URL that I just dropped in the chat, you can unlock it and play around with it. Cool, well, that's all I have for today. I hope you can join again next week when we dig more into using Gatsby with Neo4j. So we'll see you next week. Cheers.